Hey everyone, Mr. Fritz here, and we're going to talk about the change of base and solving logarithmic equations. Let's dive right into it. We have a change of base property. Did you know that you can actually change the base of a log? You can. This part you don't need to write down, but I want you to just kind of observe where this comes from. We have some logarithmic equation here, log base b of a equals x. You can convert this to exponential form and then say that b to the x must equal a. So what can we do with that? Well, we can take the log of both sides of this thing. Let me actually rewrite b to the x equals a. If I were to take the log of both sides, then this is still a true equation. In fact, I can make right now the log is a base 10, but I can make this any base I want. So let's call it base, I don't know, c. Why not? That means that it could be any number. From here, what can I do? Well, I can end up solving for x. If I use that power property, x comes out in front here. Let's change that over to x times log base c of b equals log base c of a. If I want to solve for x, I divide both sides by log base c of b. And I get x equals log base c of b. Oops, sorry, no, a, make that an a. X equals log base c of a all over log base c of b. And if this handwriting is pretty poor, my bad, maybe you can take a look at this. This is a little bit nicer. In general, if we have some log with a base b of a, this is what I would like you to jot down in your notes here. I can change this base to any number, c, into log base c of a over log base c of b. And the way that I remember this is the number that's down low goes down low. The number that's at my input, this goes up high. So I'm not like crossing over at all. I'm just creating a fraction of these logs. I can make the base anything I want. Why would this be strategic? Well, mostly for calculator use, but sometimes when we're solving certain problems, we're going to want to know this property. So for example, if I had log base 4 of 12, I could change that into log base 10, the common log. That's equal to log of 12 over log of 4. Actually, I wrote that so it looks like a base. Let me try that again. Log of 12 over log of 4. Both of these have a base of 10. This is something I can calculate in my calculator quite easily if I don't have that log base button. And here's another example. Let's do this in another color. As a note, we haven't really talked too much about the natural log, but the natural log is defined as a log with base e, the irrational number. So really log base e of x is the same thing as the natural log of x. It's a pretty common log to use, a popular log to use, and rather than just writing log base e all the time, we call it the natural log. So I could rewrite log base 4 of 12 also as the natural log of 12 over the natural log of 4. And actually there's a natural log button on your calculator as well, so good stuff. Let's see how we can use this. We want to evaluate log base 2 of 9 to 4 decimal places. Well, we can write this with a common log, log of 9 over log of 2. We could also write this with natural log of 9 over the natural log of 2. At this point, we've got to go to the calculator. This doesn't evaluate to a nice number. So let's pull out that calculator. Let me clear out all this stuff, and I can type in the log of 9 divided by the log of 2. And here's my answer, 3.1699. And just for proving that this is actually the same with the natural log, let's take the natural log of 9, divide that by the natural log of 2. And what do you know? I get the same thing. So this is 3.1699. So this equals approximately 3.1699. Why don't you try an example kind of like that? Use the change of base formula. Don't just plug it in like this in your calculator if you have that function, and try to find the answer to this problem. All right, and here's my answer to the first you try problem. Hopefully it went well.